welcome to week 7 of Signs and Symbols, Enhancing Science Instruction Through Literacy in the MCCS Era. I can't believe that we're already on week 7 and on our next and final theory, which is situated cognition. And this theory began with Leib and Wenger in 1991. So the most appropriate reference for all of situated cognition and communities of practice is Leib and Wenger. And for your readings this week, you'll be reading about them and their theory, and then also in the overview video, it talks more about Leib and Wenger. So those are important names to keep in mind in terms of situated cognition. So what are some key ideas of situated cognition? Well, one basically is that all learning is situated. So learning is participation and happens through both conscious and unconscious adoption of the behaviors and belief systems of social groups. And so this means that learning needs to be understood within a context because learning is always taking place within a particular context. And so situated cognition is really arguing that it's difficult to separate learning from the context in which it's occurring because what we do and how we think is so tied to context or to the situation. So it's important to note that some of this learning will happen consciously and other parts will be unconscious, right? Because we can learn things even unconsciously, right, without necessarily setting out to learn them. And this kind of relates back to what we talked about when we talked about social cognitive theory, learning from observing others, right? We learn all the time, probably without consciously setting out to do so. So some examples of situated cognition would be immersion language learning, apprenticeships or on-the-job training, learning how to drive, many social behaviors, and all sorts of things. I'm sure you all can probably think of other examples as well. A key idea within the theory of situated cognition is communities of practice. Communities of practice are a group of individuals that share a concern or passion for something they do and strive to improve as they interact over time. So some examples of communities of practice would be a tribe learning to survive, a group of engineers working on similar problems, a group of teachers working together to improve their practice. A functioning and effective PLC or professional learning community is an example of a community of practice. So the diagram here shows that within communities of practice there are 3 key features: authentic activities, legitimate peripheral participation, and cognitive apprenticeship. In order for our students to form a community of practice and engage in situated cognition, we need to provide them with authentic activities. In some cases, this will be simulated environments where they're able to solve a problem. In other cases, we will be able to provide them with real-world problems that they can solve that can make an impact on their community or the larger science community. Communities of practice allow the participation of all members. In some ways, we could say they allow for natural and authentic differentiation. Because within a community of practice, this sort of happens naturally and is called legitimate peripheral participation. And what this means is that new or less skilled members of the community are able to engage in low-risk tasks that introduce them to the community and allow them to further the goals of the community while they learn. So one example that I often give is a study that was done on Yucatan midwives and how they taught the youngsters, usually their daughters, the practice of midwifery. And so the girls would begin to participate in the births, but they would begin by doing things like bringing fresh water or clean towels, things like that, right? Pretty low-risk things, but that are also important in the birth process. So that's what we mean when we're talking about legitimate peripheral participation. And then as you learn, you grow more towards full participation. So the final piece, cognitive apprenticeship, is where we allow students to learn in a domain by allowing them to acquire, develop, and use cognitive tools that are authentic to that domain. So in science, this means that we are providing students the opportunity to learn science by acting like scientists. We always want to be thinking about how to provide experiences that allow students to think like a practitioner or to think like a scientist. So one example of this is epistemic games. With epistemic games, the goal is for students to take on the role of an urban planner, an engineer, etc., some sort of profession, and to learn how to think, talk, and act like someone in that profession. Or in other words, learn to take on an identity in order to engage in meaningful work and learning. So Dr. David Schaefer, who runs the Epistemic Games Lab and is really the person behind a lot of this epistemic games work, for example, describes epistemic games as learning environments that are designed explicitly to help players develop ways of seeing and solving problems that matter in society. And he believes that these environments have the power to help shape how young people see themselves and the world around them. So we have a couple of examples for you to watch, and these are also on the Moodle site overview, the links to these videos. One is just an overview, talking more so about what epistemic games are and the goals, and another is a specific engineering example that some of you, might be able to see a closer relation to science and engineering. So a common question with these is, where can I get these? These particular games aren't widely available yet. However, if you are interested in them, you can contact the researchers through the Epistemic Games website. If you just Google Epistemic Games, it will come up, the lab, David Schaefer's work. You can certainly get in touch with them. But one reason that we're presenting these to you is that you can also use these ideas as a springboard to think about ways that you can create these kinds of experiences for students in your classroom. So that's really kind of at the heart of what we're asking you to do this week, is to think about how you could create these kinds of experiences, what the benefits of these experiences might be, thinking about communities of practice. You have a reading that you're doing that's really relating and talking more about a community of learners. So thinking about how do we foster a community of learners in our classroom in order to do science, and then again to connect to the Montana Common Core standards. How can doing something like this and making things authentic for students help to engage them in building these literacy practices? So as I said, that's what I would encourage you to think about as you do the readings and the rest of the work and the examples for this week. Thank you, and it's been fun talking about theory these past 4 weeks.